for this problem, the first thing we're going to want to do, and we discussed this last time, was we have to make sure that the equations are both in the same form, but we can see that the second equation is a negative 2y equals, whereas the first one is negative 6x plus 5y equals. So they're not even in the same format right now. Now, I do want these two equations to be in the format of this first one right here, okay? So that's the format I do want it in. That's called standard form, which means I don't want the negative 6x on this side of the equal sign for this second equation, all right? So just a quick principle of equality, right? We're going to zero that out, which essentially moves it to the other side of the equation. I'm putting that under the negative 2y because we're kind of used to doing that. But remember, these aren't like terms, so we have to kind of keep these separated. And I'm going to put them in the same order as this equation in black, right, with the negative 6x and then the 5y. So I'm going to put my x's is the first term, and then the y's will be my second term. So that's going to be 6x minus 2y, which equals this negative 6. We're just going to drop that right there. And then, of course, the negative 6x right there canceled out to zeroed out. Now, I'm going to write that first equation again. It was a negative 6x plus 5y equals negative 3. Just so we can see the two equations together. And the just analysis on this, right? We now have moved them or manipulated these two equations so that they're in at least the same format. But again, another quick analysis shows that the coefficients of x are opposites. So that means if we go straight into adding these two equations together, that it's going to zero out the x's or eliminate them, right? So now I'm looking at the y's. I got negative 2y plus 5y, which would be 3y right there. And this equals negative 6 plus negative 3, which is negative 9. Yeah, it's going to turn out real good. Just divide both sides by 3, and we get y equals negative 3. Now, that's the y value, though. All right, so I got y equals negative 3, and just between the two equations that I'm seeing, I'm not sure that one is really easier than the other one to solve, but I would look at the second equation for myself, right? I'd say, well, negative 2y equals negative 6 minus 6x. Now, again, it doesn't matter which of the two equations you chose. And yeah, I'm looking at the two original ones in black. Either one should work because the y value is going to be the same for either of the, and the x value is going to be the same for both equations. So I'm going to replace that y value with this negative 3 that we just solved for. And from here, I'm just going to solve this equation for x. So, you know, say negative 2 times negative 3, that's 6. So we got 6 equals negative 6 minus 6x. And then I would get rid of that negative 6 by adding 6 to both sides. So that zeroes that out. 6 plus 6 is 12, which equals, I'll drop this negative 6x right there, and then divide both sides by negative 6. So that gives us x equals negative 2. So we got the two values, right? And it was good to see those of you that have done the written assignment for this. I know that's ahead, right? We're going to review for that, but yeah, we can see if you want to write this as an ordered pair, you could, because on a graph it would be the point of intersection. But the last thing you'd want to do on this, you guys, is just check. So in my calculator, I got negative 6 times x, but right here x is negative 2, so negative 6 times negative 2. And then plus 5 times y, but y now is negative 3. And when I push equal, I get negative 3, that's good. On the other side, I already know negative 2 times negative 3 is 6, that's good. But I got negative 6 on the other side of that equal sign minus 6 times x. And we said x is negative 2, so 6. Yeah, there we go. So it checks off in both cases, and we can, you know, put that answer down with a little bit more confidence.